We have seen through observing phenomena in nature, such as spirals or flower petal counts, that a certain sequence comes to mind, and it is the Fibonacci sequence. So I'll write out the first few numbers. As you saw in Vihart's video, we don't have to start with the number 1, but we will start with 1, 1 in our class. And so we just add 2 to get the next. So we have 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, let's just write out a few, 89, 144, and so on. And of course, and so on means that we could continue by just adding 2 to get the next one. In this video, I would like to introduce you to notation that is used with the Fibonacci numbers and makes life actually much easier than harder. So here it is. We'll call, first I'll give it to you in general, capital F sub n. Notice that the n is a small font lowered as a subscript. Fn, we say, or F sub n, is the nth Fibonacci number. I'll just put fib. The nth Fibonacci number. Now, n can take on the values 1, the first one, 2, 3, 4. N takes on the values of the natural numbers. So if I write f sub 1, you know that that is the first Fibonacci number, which is 1. And f2, f sub 2, is the second Fibonacci number, and I just count over twice, and I see the second one is also 1. Well, let's try f6, the sixth Fibonacci number. When you see f sub 6, in your mind, say the words, the sixth Fibonacci number. So you just count over 6 places, and you see that 8 is the sixth Fibonacci number, so we say f6 is equal to 8. Well, how about f10? The 10th Fibonacci number, let's see, there's 3, 4, 5, 6, 7, 8, 9, 10, is 55. Is the equal sign. The 10th Fibonacci number is 55. That's how you read that. It's very important for you to read symbolic notation in sentences in your mind. These are just shorthand notation for full sentences in your mind. Here you see I've written out the Fibonacci's at the top of this slide here. And let's see if we can answer this question. If n is 6, what is f sub n plus 3? Okay, so look, the n plus 3 is part of the subscript, and n is 6. So this is f sub 6 plus 3 is 9. It's the 9th Fibonacci. So we see that certainly A is true. It is the 9th Fibonacci. That's true. And what is the 9th Fibonacci? 1, 2, 3, 4, 5, 6, 7, 8, 9. It is equal to 55. So just part A is true. Now I'd like you on all of these slides, they're multiple choice questions. I'd like you to pause and try to do the question yourself and then play my solution. Okay, so first notice again that I have written the Fibonacci's at the top for you, and on any test I will write out the first few for you. So put it on pause and see if you can solve this problem. Now I'll solve it. F3, that is the third Fibonacci, which is 2 counting over plus f sub 7, the 7th Fibonacci, would be 13. So 2 plus 13 is 15, and I find that part B is true. I don't know how A and C could possibly be true. That answer doesn't make sense, but the answer is part B. It is equal to 15. The next question, let n be 5. What is f sub n plus 2 plus f sub n minus 2? You put it on pause and see if you can solve it. Okay, so be always careful. When you write, you've got to be very careful to be clear as to what is the subscript and what's on the main line. Here we see that the subscripts are n plus 2 and n minus 2. And let me just show you what students will write sometimes. Let's see, I'll change colors here. Let me do yellow. Sometimes students will mean F6 and they'll write this. Well, you don't know what that means. Or f sub n plus 2. They'll write f sub n plus 2 like this is written properly here. A student might write this and then something like that. Well, I can't tell if that is f sub n plus 2 or f sub n plus 2. Here the 2 is added to the subscript, and here the 2 would be added to the nth Fibonacci number. So be very, very careful with your notation. So back to this problem. This problem was f sub n plus 2. Well, n is 5. So 5 plus 2 is 7. This is the 7th Fibonacci plus, and n minus 2. 5 minus 2 is 3, so that's F3. Now the 7th Fibonacci, if you count over, is 13. And the 3rd Fibonacci, counting over, is 2. And 13 plus 2, of course, is 15. So our answer is 15. Okay, so here we have 5 times the 11th Fibonacci plus 11 times the 5th Fibonacci. It's just like writing in high school, you wrote 5x, meaning 5 times x. If I write the 5 before the Fibonacci notation, it means 5 times F11 plus 11 times F5. So let's see, that will be 5 times, I use a dot for times instead of x's, F11. Well, what's F11? 2, 4, 6, 8, 9, 10, 11. 5 times 89 plus 11 times F5 is 5. 5 is the 5th Fibonacci. So you can multiply that out by hand or on your calculator and you'll get 500. So this is equal to 500, and we pick choice C. Okay, again, I hope that you had put this on pause and have done this yourself. Here we see that the parentheses tell us that we are squaring. Notice that's an exponent, superscript, that we are squaring the 6th Fibonacci. So the 6th Fibonacci, counting over, is 8. So this is 8 squared, or 64. The answer is C. Now this problem, again, the parentheses tell you that you are squaring a number. And that number is 2 times the 7th Fibonacci. So let's see, I'll keep the parentheses on and write 2 times. The 7th Fibonacci is 13. So this is equal to 2 times 13, which is, oh, excuse me, I should have put the square here. 2 times 13 is 26. and we are squaring 26, which is 676. It's 26 times 26 is 26 squared. So choice B. So this one might be a little trickier. Here it says let n be 2. And then it gives us an expression involving n in 3 different places. So all you do is rewrite that expression, plugging in 2 for n. So it's very mechanical. This will be f sub, well, 2 plus 2 is 4, f4, and if you want, you could keep parentheses on it. We're going to be raising it to the power n, but n is 2, so we're going to be squaring it, minus 5 times 2 is 10. So you just plug in n, and now we'll carry through. Our parentheses tell us to square the 4th Fibonacci, which is 3. So that is 3 squared minus 10, or 9 minus 10 is, of course, negative 1. So our answer is part A. Okay, so let's see if you got this one right. Here, n is 4. So the first thing I do is just plug in 4 for n. Replace n with 4 everywhere I see it. So I have f sub 4 minus 1. So that's f3 cubed minus 5. The 3rd Fibonacci is 2. So that's 2 cubed minus 5. 2 times 2 times 2 is 8. So this is 8 minus 5, or 3. So part B. If we were to write out in words how do you generate the Fibonacci sequence, we would have to write a sentence that, well, you start with 1, 1, and then you add 2 to get the next number in the sequence. Now, if you write out all those words, that's quite a long sentence. Mathematical notation gives us a wonderful way of writing things that would take long sentences in just a few symbols. So let's see which one of these 3, or are there more than one, that tell us how to generate the Fibonacci sequence. In part A, I think a good way for you to look at this at first, instead of thinking of f sub n minus 1 plus f sub n, think of it just like in your mind, let n be 5. Let n be anything. Whoops. And here, for example, if n was 5, let's just write what this says. It would say the 4th Fibonacci, f sub n minus 1, plus the 5th Fibonacci, f sub n, would be f sub 5 plus 1. Ah, well, that's true. That's true. How about this one down here? F sub n minus 1 plus f sub n. Oh, it's the same thing. So this also would say, if n was 4, it would say that, if n was 5, it would say that f4 plus f5 is equal to f6. It's exactly the same sentence. And then what would part C be? Well, if n were 5, that would say that f5 plus f6 is equal to f sub n plus 2. If n were 5, n plus 2 is 7. Oh, well, that's true too. So all of these expressions here, it's true that if you take a Fibonacci, f sub n, and you add, I think of the word next. If you have the nth Fibonacci and you add the next one to it, that you get the next one after that. This says exactly the same thing. If you have the nth Fibonacci and you add it to the one right before it, you will get the one right after it. Play this over and over until you can see how my words translate these expressions. But maybe they're not all true. We also have to look at what the values of n are. So let's go back to the first one here. We know that for any particular value of n, this is true. This said for n equals 1, 2, 3, and so on. But if n is equal to 1, what this would say would be f sub 0. That would see f sub 0 plus f1 equals f2. And that doesn't make sense because we don't have a 0th Fibonacci. So 1, if we are going to write the generating formula as we did in part A or B, if that's the way we want to write the generating formula, we have to start at n equals 2. If n is 2, we have f1 plus f2 equals f3, and so on. So B is one way to write the generating formula. And fn plus fn plus 1 equals fn plus 2 is also correct, and we would start with n equals 1. So you get f1 plus f2 equals f3, etc. So this is fine too. Both of these are expressions or equations that tell you how to generate the Fibonacci sequence. Notice one other important thing. Not only do you have to know what the values of n are after you state this generating sequence, you need to know what the first two Fibonacci's are, because otherwise you couldn't follow the instructions. So we must know that f1 and f2 are both 1, and then you know how. Then from there on, you can just use this generating formula. So both B and C are true.